the semester project here. So here are the outlines on the left and Logisim on the right to bring it up. Let's go through what we're doing. I went through these tasks here and took the microprocessor schematic provided by the teacher to operate through it, and then update the ALU, and then create a control module for it. Right now we're doing video 1, an overview of the ALU. So let's take a look. So here's the original microprocessor, the main layout being the the main processor here with the ALU. Accumulator buffer out, and then that will write down into the memory. This is the random access memory it writes to. There is ROM read-only memory, and then there is the address selector for each of these, and then the clock and read and write. So here I am the manual module, the human module that controls this, and we wanted to create a control module that will automate all this. So anything that you see that you can click to make this go, like address, read, write, A or B, enable B, select, enable accumulator out, can be swapped out with a next state table, creating logic functions for that, and then wiring them up. First task was to blow the ALU mini up. So this is what the original design looked like. It's a 4 function with demuxes here. You have your typical step mux to create a 2-bit selector. So since there's 1, 2, 3, 4 modes to go in, you'll need 2 bits to have 4 different combinations to select from. You create the muxes in the lower bit, least significant bit, and then the most significant one, you create a sorry. So you create what those 2 muxes go into to create the final combination of all the modes. We have our 4 inputs here, which will be the numbers that we pass through it from our read-only material and then put out to the rest of the unit. This is just the device. This is the one I created based off of that. So I copied and pasted from the ALU mini, labeled number 2 here, you can see. This is 8 functions now, as said in the task to do. I added all bitwise functions. I chose bitwise functions because they were the most straightforward operations to do. You can see I built them here. A and B pass through an OR gate bitwise, 4 bits out. XOR and NAND. I took those devices here and added them, and then added the extra muxes needed in order to create a 3-bit selection, which is what we'll need to select between 8 different kinds of combinations. So let's test some of those out. Let's just try the first one, A minus B. Let's try 2 minus 1, and we will run that. 0, 0, 0, and you can see the output is 1. Now let's change the selection to 1 to add them together, which will expect a 3 on the output. So let's click this here. You can see 3 on the output. Now let's go with multiply, and that is 2. Anything multiplied by itself, 1 is itself, that's expected. Now let's do 3. MS4. Now let's do bitwise OR. That is 4. This compares each bit with the other bit in the same digit position. So 1 ORed with 0 is going to be 1, and 0 ORed with 1 is going to be 1. Let's try 6, the AND. That would be this here. And 1 ANDed with 0 is 0, and 1 ANDed with 0 is 0, right? So that's that output. Let's take a look at the other questions here. Multiple operations, we just went through that. Show internal circuit and explain strategy for selecting chosen operation. Well, I discussed that. Discuss why it's useful to have a multifunctional calculator like this at the center of microprocessor. This is really important because you want your devices to do more than one thing. So let's say this is a direct output to user to view. You can do multiple functions. It's like having a frying pan at your kitchen counter. You can fry many things in it, not just one thing. You can put an egg in there, you can put bacon, you can put steak. You can do many different things. Now let's do something more abstract where this ALU is not a direct output to the user of seeing the operation. So you can take bits coming in here. Let's say you're coding at the assembly level or an abstract level somewhere between the interface and the machine. Well, you can do many different things with this. You can shift bits, you can bitwise bits, you can add, subtract in order to code different functions for your machines to do. And that's it for video 1. Thank you.